Welcome to SQL Basics Part 3. In this part, we'll quickly understand some important SQL concepts every beginner should know. Important SQL differences that every data professional should understand? Let's break them down quickly. First, having versus where. The where clause filters rows before grouping happens, but the having clause filters after the group by, meaning it works on aggregated results. Next, union versus union all. Union combines results from multiple queries and removes duplicate rows, while union all also combines results but keeps all duplicates, making it faster. Now, delete versus drop versus truncate. Delete removes specific rows and allows filtering with a where condition. Drop completely removes the table or database structure, and truncate deletes all rows but keeps the table structure intact. Let's look at CTE versus temp table. A CTE, or common table expression, is a temporary result used within a single query. A temporary table is a physical table that exists for the duration of the session. Finally, except versus not in. Except returns rows that exist in the first query but not in the second. Not in filters rows where a column value is not in a specified list. Mastering these SQL differences can make your queries more efficient and interview-ready. In SQL, understanding the difference between where and having is very important when filtering data. Let's start with the where clause. The where clause filters individual rows before grouping happens. For example, if we want to retrieve orders placed after January 1st, 2024, we can write a query that filters rows using the order date condition. This step ensures that only the relevant records move forward for further processing. Now let's look at the having clause. Having works after the group by operation and is used to filter aggregate results. For example, suppose we want to find products where the total quantity sold is greater than 200 units. We first group the data by product ID and calculate the total quantity using the sum function. Then, having filters the grouped results based on that aggregate value. So remember this simple rule. Where filters rows, while having filters groups. Let's understand how where and having work together in a SQL query. First, we select the product ID and calculate the total quantity sold using the sum function. Next, the where clause filters rows before grouping. In this example, we only include orders where the order date is after January 1st, 2024. After filtering the rows, SQL performs the group by operation, grouping the results by product ID. Finally, the having clause filters the grouped data. Here, it returns only the products where the total quantity sold is greater than 200. So the execution flow is simple. Where filters rows first, group by aggregates the data, and having filters the grouped results. Mastering this concept is essential for data analysis and SQL interviews. In SQL, union and union all are used to combine results from multiple select queries, but they behave differently. First, let's look at union. The union operation combines two result sets and automatically removes duplicate rows. This means the final output contains only unique records. For example, in this query, we select employee job titles and assign a pay type. One query retrieves salaried employees, while the other retrieves hourly employees. When we use union, SQL merges both lists and eliminates duplicates, giving us a clean and distinct result set. Now, let's look at union all. Union all also combines results from multiple queries, but it keeps all records, including duplicates. In this example, we retrieve last names from employees and customers. Because union all does not remove duplicates, every record from both queries is returned. The advantage is better performance, since SQL does not spend time checking for duplicates. So remember, union equals removes duplicates. Union all equals keeps duplicates but runs faster. Understanding the difference between truncate, delete, and drop is essential for working with SQL databases. Let's start with truncate. Truncate is used to remove all rows from a table instantly. It's super fast because it doesn't scan each row. But remember, it keeps the table structure intact so you can reuse it immediately. Next is delete. Delete is more flexible. It allows you to remove specific rows using conditions, like a where clause. However, because it processes data row by row, it can be slower compared to truncate. Finally, we have drop. Drop is the most powerful and dangerous. It completely removes the entire table, including its structure and data. Once you use drop, the table is gone permanently. So, in short, use truncate for speed, delete for control, and drop when you want to remove everything completely. Choose wisely based on your use case. Let's do a quick comparison of truncate, delete, and drop in SQL. Starting with truncate, it removes all rows from a table instantly. You cannot use conditions and it's not reversible. However, the table structure remains intact, making it ready for reuse. Next, delete. Delete allows you to remove specific rows using conditions like a where clause. It's more flexible and can be reversed if used within a transaction. And just like truncate, the table structure stays. Finally, drop. Drop completely removes the entire table, including both data and structure. There are no conditions and it is not reversible. Once dropped, the table is gone. So here's the quick takeaway. Use truncate for fast, full data removal, delete for controlled row-level deletion, and drop when you want to remove everything permanently. Here's a quick summary of truncate, delete, and drop in SQL. Truncate quickly removes all data from a table but keeps the table structure intact. It's fast and ideal when you want a clean slate. Delete is used to remove specific data using conditions. It gives you more control but can be slower since it works row by row. And finally, drop. Drop completely removes the entire table, including both data and structure. Once executed, the table is gone permanently. So remember, truncate for speed, delete for control, and drop for complete removal. Let's understand the difference between a CTE and a temporary table in SQL. First, what is a CTE? A common table expression, or CTE, is a temporary result set that exists only during the execution of a single query, like select, insert, update, or delete. CTEs are great for breaking down complex queries into smaller, more readable parts. They make your SQL cleaner and easier to maintain. Now, what is a temporary table? A temporary table is a physical database object that stores data temporarily during a session or transaction. It is stored in TempDB and is ideal for handling large data sets or when you need to reuse intermediate results multiple times. So here's the key difference. CTEs are lightweight and query-scoped, while temporary tables are more powerful and reusable. Use CTEs for simplicity and temp tables for performance and reuse. Let's look at how to use a CTE and a temporary table with examples. Starting with the CTE. We define a CTE using the with clause. Here, we calculate the total order amount per customer using sum and group by. Then, in the main query, we simply select from the CTE and filter customers where the total amount is greater than 600. This approach makes the query clean, readable, and easy to manage. Now, let's look at the temporary table. First, we create a temp table called #HighValueOrders. Next, we insert data into it by selecting orders where the amount is greater than 400. Finally, we retrieve the data using a simple select statement. Temporary tables are useful when you need to store and reuse data across multiple steps. So, remember, use CTEs for simplicity and readability, and temp tables for reusable and large datasets. Wondering when to use a CTE versus a temporary table? Let's break it down. Use a CTE when you're working with complex queries that need better readability. It's perfect for simplifying logic into smaller parts. CTEs are also great for recursive queries and when dealing with small, non-reusable datasets that are only needed for a single query. Now, when should you use a temporary table? Temp tables are ideal for large datasets and scenarios involving multiple joins on the same data. They're also useful when the data needs to be reused across multiple steps or queries. So here's the takeaway. Use CTEs for simplicity and readability, and temp tables for performance and reuse. Let's understand the difference between except and not in SQL. Except is a set-based operation. It compares two result sets and returns only distinct rows. Duplicates are automatically removed. Not in works differently. It filters rows one by one and keeps duplicates in the result. Now, the most important difference, null handling. Except treats null values properly, but not in can return unexpected results if the subquery contains even a single null. Another key point, except requires both queries to have the same number of columns and compatible data types. Not in only compares a single column inside a where clause. In terms of performance, except is usually better for large data sets, while not in works fine for small, simple queries. Choose wisely depending on your use case. Let's understand this with an example. First, we use the except operator. Here, we select ID, name, company, and CARS from CARS 1 and remove all matching records that exist in CARS 2. The result gives us unique rows from CARS 1 that are not present in CARS 2. Now, let's do the same using not in. We again select data from CARS 1, but this time we filter using a where clause. We only keep rows where the ID is not in the list of IDs from CARS 2. So both queries aim for the same result, but except works on full rows, while not in focuses on a single column. When should you use except versus not in? Use except when you need a clean and distinct list of rows that are not present in another table. It's ideal for large data sets and works well even when null values are involved. On the other hand, use not in for simple row-based filtering. It works best with small and static lists. But be careful, only use not in when you are sure there are no null values in the subquery. Choosing the right one improves both accuracy and performance.